In this next lesson, we'll be graphing systems of linear inequalities. A system of linear inequalities is just two or more inequalities using two variables, usually x and y. And a solution is a collection of points that make all of the inequalities in that system true, and it will show up as a shaded area. So here are the steps you're going to follow when you go to solve a system of inequalities. First, you're going to graph each of the individual inequalities. Keep in mind you're using solid lines and dashed lines, and you're figuring out which side of each line to shade. And then you're going to see where the shadings overlap, and then that overlap is your final answer. It's similar to the and inequalities that we solved in one variable, where you shaded part of the number line where the two rays overlapped. So here's our first example. Y is less than opposite of x plus 3. That's in y equals mx plus b form. Recall that your first step to graphing an inequality is to pretend like it's an equal sign. So pretend like it's y equals the opposite of x plus 3, which means that the b value is 3, which means that this graph has a y-intercept at the point 0, 3. And then the m value would be -1, which as a fraction would be -1/1. So from our y-intercept, we're going to go down one, right one, down one, right one, down one, right one. And we'll repeat that several times. And you can also go up one, left one. Now our inequality is a strictly less than sign, which means that when we go to connect those points, we're going to be using a dashed line. Remember, we like to use 0, 0 as a test point if we can. So we're going to go back to our first equation and plug in 0, 0. Which means putting in a 0 for y and a 0 for x. And in this case, we'd end up with 0 is less than 3, which is true. So when we go to shade the first inequality, we're going to shade on the same side as our test point, which is kind of below and to the left. So all of these values are values that are solutions to that first inequality. Now we're going to repeat this with the second inequality. X plus 4y is greater than or equal to 4. So this inequality is in standard form, which means it might be good to find the intercepts. So to find the x-intercept, remember that is when you plug in a 0 for y and solve for x. So we'll do x plus 4 times 0 equals 4. And we get x plus 0, which is x, and x equals 4. So the x-intercept of the second equation is at the point 4, 0. Go ahead and plot that one. And then the y-intercept, we'll find that by plugging in a 0 for x. And we'll get 0 plus 4y equals 4. And solve for y. And we'll get y equals 1. So now we will connect the blue line with solid because there's an equal to as part of that inequality. And when we do our test point of 0, 0 again, we'll go back up to our original here and plug in a 0 for x and a 0 for y, and we get 0 is greater than or equal to 4, which is false, which means we will not shade down and to the left where our test point is, but we'll shade up and to the right where our test point is not located, since we got a false statement. So everything in this blue area is a solution to the second inequality. And then our final answer is the place where the two inequalities overlap. So where we have red and blue make purple, that is everything inside of this little kind of almost not quite triangular type shape, but over here. So you'll go back and you'll either make that very, very dark, or your other option is that you could go back and you could erase the extra shading that you don't need because it's not an overlap. Either one would be an okay way to show your final answer. It's probably easier to do the original shadings very lightly and then do the overlap much darker, and that is a little less work than going back and erasing the original shading.